This slide shows the simulation of the battery-dominated power system with uniform voltage distribution maximum power tracking control, emphasizing the sourcing circumstance that change between two sourcing parameters. The trajectory of purple color shown on the plot on the left side is the trajectory that showing the transition of the peak power steady state between 1170 watts to 1357 watts. The parabolic curves are the static DC characteristics of three power sources. The upper curve corresponding to when these three power sources have different voltages of 80 volts, 60 volts, and 50 volts respectively. The upper curve. For the lower curve, the power source have the same open circuit voltage of 60 volts. The plot on the right side shows the corresponding time domain simulation, reviewing the total sourcing power PSRC on the top plot shown on the right plot of the chart. On the middle plot on the right side of the plot, showing the sourcing voltages V1, V2, V3 having 20 Hz digital signal superimposed on their operating point of around 32 volts DC. This power source voltage and total power source delivered to the system processed in XY mode and plot in purple trajectory being overlaid on the static PV characteristics. The tracking efficiency that achieved is 98.8% at the power of 1340 watts. This slide shows the simulation of the battery-dominated power system with respect to 5 amp step load directly across power source number 1, as shown on the plot on the left side. Also, the step load 600 watts across the battery bus voltage also performed in a separate simulation run. The response is shown on the right side of the chart. Under both step transient, either 5 amp transient across power source number 1 or 600 watt step load across battery bus, the system distributed sourcing voltages robustly track the system peak power voltage of around 32.2 volts DC. This simulation for both types of step load, based on the three power sources having open circuit voltage of 80 volts, 60 volts, and 50 volts for power source number 1, power source number 2, and power source number 3 respectively. This slide reviews the simulation result for the regulated bus power system, showing the step load response between the 0.2 amps step load and 28 amp step load across the system regulated bus V out. As can be seen on the bottom plot, the system output voltage regulated as 28 volt DC without noticeable or observable transient. During the step load transit to 28 amps, the system operates in maximum power tracking mode, in which the sourcing voltage V1, V2, V3 shown on the middle plot settle at their peak power voltage around 32 volts DC. As soon as the load steps back to very light load, such as 0.28 amps, the three sourcing voltage increase to around 40 volts and still remaining uniformly distributed or equal, without 20 Hz digital AC ripple superimposed on them. During the step load go to the light load, the battery current have a chance to regulate at its target regulation of 50 amps. This is because the system have enough power to charge the battery. During the maximum power tracking mode, the load already absorbed 28 amps. As a result, the battery charging current could not reach the target value of 50 amp. Only around 14.3 amp is charged into the battery. Let's focus on the ability to tolerate the faults. This slide shows the simulation result demonstrate fault tolerance. A failure of one power source is introduced into the system. For example, the failure of power source number 3. As a result, the remaining distributed sourcing voltages V1 and V2 are well tracked at the system optimum power voltage to maintain high power tracking efficiency, as can be seen on the middle plot. This slide continues to show the fault tolerance capability to simulation. Power source is set to fail one at a time, such as power source number 3, and then power source number 2, and then power source number 1. After that, all three power sources are restored back to normal. That is why the sourcing power showed different optimum power level, as 1140 watts or nearly 1000 watts in another occasion, and down to around 600 watts in the third condition. Finally, when all power sources are restored back to normal, the highest peak power is achieved around 1357 watts. Again, this emphasizes the ability to tolerate one power fault.